In the previous video, we looked at how we can use Excel to calculate a number of statistical variables. We looked in particular at how we can use Excel to calculate mean, variance, standard deviation, product moment correlation coefficient, and also the A and B values, which are used to define regression lines. Now in this video, we're going to repeat that process, but this time we're going to look at some slightly different data. And in particular, we're going to be looking at sample data. So we're going to use the same scenario. We're going to assume that this data has been collected by a production manager, and the production manager is trying to establish if there's a relationship between the number of staff that he employs and the overall production. Now, when we looked at the population data in the previous video, we found that there was a strong correlation between those two sets of data. But let's assume that the staff were aware that that study was being conducted. They may well have adjusted their behaviours to influence the outcomes of the studies. So this time what the production manager has decided to do is to take one day of every month randomly and use that data to inform his decision as to whether these two variables are connected. Now hopefully you can see why that would be sample data rather than population data, because all we're doing is we're taking one day of every month. If the factory's open every day of the month, then that's potentially 29 days where we're not taking data from. So what we're looking at this time is a sample of data, not a complete set of data. Therefore, we're going to have to use the formulas that relate to sample data rather than population data, but the process is very similar. So let's begin by calculating the mean of our X data, and once again, our X data is our number of staff here. Now in the blue box, this is what we're going to do using Excel, and then I'm going to show you some of the additional functions that you'll have on your calculator where you can replicate the calculations that Excel does when we apply these formulas. So again, you'll have a third method for calculating these variables using your calculators. So first of all, the mean average of our X data, and the formula is exactly the same as before, equals average, open brackets, and then we highlight our X data. Now at the moment we don't have any way of checking that, but we'll have to assume that it's accurate. We're going to do the same for our Y data, equals average, open brackets, and highlight our column of Y data. Next we want the variance of our data, taking care because this is sample data. So first of all, we're going to take the variance of our X data, which is done by doing equals var dot s this time because it's sample data, open brackets, highlight all the data by left clicking, close the brackets and hit enter. Let's do the same for our Y data, equals, it's still sample data, so var dot s, open brackets, highlight the data, close brackets and hit enter. What you'll notice here is that we're using an S to denote standard deviation rather than the symbol sigma, and that's because we're using sample data, not population data. It's another way of reminding us what type of data we're using. And the standard deviation is just the square root of the variance. So our function here is equals sqrt, open brackets, and then click on the variance cell for the X data. And then we're going to repeat that for the Y data. So equals square root of the variance of the Y data, which is the 54.75. Now hopefully you recall that the way that we got our product moment correlation coefficient and the A and B values of our regression line was by plotting a scatter graph. So I'm going to highlight all my data again and plot the scatter graph of X against Y. Insert scatter graph, and the type I'm going to use again is with just the points rather than with the connecting lines. Now for completeness, I'm going to add my chart labels. So I click on design, quick layout here, and I'll have the option to add my chart title and axis labels. I'm going to use the same title, relationship between number of staff and production. On my x-axis, I have my number of staff for a given day. And on my y-axis, I have my production. Next, we added a trend line, and when we add the trend line by right-clicking on one of the data points and add trend line, we had the option of displaying the formula. Now, first of all, we need to make sure that we have a linear trend line selected, and then we want to click on display formula here at the bottom, and we also want to click display R squared value, which is the product moment correlation coefficient squared. Now both of those are on my graph. Let's just move this over here so it's easier to see, and we'll make that a little bigger. And we can see a couple of things here. First of all, we can see that our value of the gradient, which is represented by B, is 0.6124. So over here, B is 0.6124 using Excel. And A is our intercept. And again, from this formula, we can see that A, or the intercept, is 182.48. So let's add that, 182.48. Now for our product moment correlation coefficient, we need to square root this value up here. This value up here says that R squared is 0.0702. So to get R on its own, we just need to square root that. So square rooting 0.0702, we get 0.265 to 3 decimal places. Now what we have this time is we have a product moment correlation coefficient between 0 and 0.3. Now a PMCC between 0 and 0.3 means that we only have weak correlation. What this is showing us from this second study is that there isn't a particularly strong correlation between the number of staff and production. This would indicate that perhaps when there's more staff, they may be distracting each other or getting in each other's way, and so production isn't actually speeding up as much as we would expect.